So for this one, you notice we're finding the equation of the tangent line, and as soon as I see the word tangent, I'm automatically thinking derivative. Because if I need to know the slope of the tangent line, that means I got to find the derivative of the function. So step one, figure out what does y prime equal. So notice here we have addition of a couple functions. So I can just find the derivative of each of those functions individually. No special rule needed. So the derivative of the 3x, of course that's just 3, plus the derivative of 6 cosine of x. Well, that's going to be 6 times the derivative of cosine. And the derivative of cosine, of course, is negative sign. And since it's negative sign, I'm going to turn that plus into a minus in between them. So it'll be minus 6 sine of x. So now that's my derivative function. I can plug in any x value now and figure out what the slope of that function is at that point. And so I now go over to my point here, and I see that the x-coordinate I'm working with here is pi over 3. So I want to now know what the slope is, so I'm going to go ahead and call it m for slope. You don't have to, obviously, but sticks with convention. M will equal 3 minus 6 times sine of pi over 3. And yes, you should know what sine of pi over 3 is. You should know your unit circle stuff. So as you're thinking about it, the trick to do it is first you should envision where pi over 3 is. Here we have 0. Pi over 3, that's like the 60 degrees. And so sine, remember sine is how far we go up or down. And so we're going up more than we're going over here. That's the bigger number. That's the root 3 over 2. So m here equals 3 minus 6 times root 3 over 2. And so we can go ahead and do that math. So that's going to be 3 minus 3 root 3. And there's not a nice tidy way to clean that up any more than that. So we're going to go ahead and just leave it at 3 minus 3 root 3. Now that's my slope. At least this is tangent line and not normal line, right?
Yeah.
But now that I know that, I can go ahead and find my general equation. So to write our general equation, we're going to go to y equals mx plus b.
Y equals mx.
So y here, my y coordinate is pi plus 3. That equals m, my slope, so that's going to be 3 minus 3 root 3, times x, which is pi over 3. Then that's plus b. All right, so solve that for b. Now as I look at this, the thing that I want to do first is I want to go ahead and distribute that pi over 3 into this set of parentheses here. So 3 times pi over 3 would be pi, minus 3 root 3 times pi over 3. Well, the 3's cancel out, so that'll be pi root 3 plus the b. And now I want to get it to be b equal, so I'm going to go ahead and move everything to the left-hand side. So I subtract pi from both sides, but you notice that when I do that, when I subtract pi from both sides, the pi's are actually going to cancel each other out there. And so then I end up with 3 plus pi root 3 equals b.
Hallelujah.
All right, now that I know that, I now have my final answer.
That is such an argument.
It's going to be y equals 3 minus 3 root 3 x plus my b, which is 3 plus pi root 3.
Oh my god.
Yes, sometimes the answers work out that way.
That's horrible.
It's all right.
Comes a new one.
Is this going to be
Now,
up here?
if that form looks really scary to you and you're thinking, wait, how would I actually use that? If we're doing this kind of work and we're actually finding like a trend line by doing this, and so we're wanting to know what is happening in a given situation that we're representing with this, you probably would then take this and turn it into decimal values. And so realize that this is what we do in exact form. It's that very abstract mathematical thing. But if you were just going to be doing a bunch of calculations or making a graph of it, you go ahead and calculate out what 3 minus 3 root 3 equals. And you calculate out what 3 plus pi root 3 equals as well. So that's more the practical side to something that ends up looking like this. So for this one, we're looking to see where it has a horizontal tangent. And again, if tangent comes up as part of the question, you can bet that you're going to have to find derivative. And we will here. So first up, I'm going to go ahead and figure out what f prime of x will equal. Now we have e to the x cosine of x. Notice that means that I have a function times a function. It's a product. And so we got to use product rule. So product rule here. Original times derivative. So that's going to be the original e to the x times the derivative of cosine, which is negative sine, plus derivative times original. Derivative of e to the x is just e to the x. And then that is times the original cosine of x.
Wouldn't it just be easier to write out e to the
Now,
x?
I'm going to tidy up the way this looks a little bit, just because it is going to make our next steps a little bit easier. And so, there's two things I'm going to do. First of all, I want to, instead of writing a negative plus, I'm going to write that as subtraction. So I'm going to write the sine second, and I'm going to put the cosine first. Also, there's an e to the x in both terms. So I'm going to go ahead and factor out that e to the x as well, which is actually going to be very helpful in a moment, as you'll see. So it becomes e to the power of x times cosine of x minus sine of x. Now by writing it in this form, I'm now going to make my life a lot easier for my next step, because if I want to know where it has a horizontal tangent, that means the slope of my tangent line, if it's horizontal, is 0. And so then I'm going to set this whole thing equal to 0. And by having it in this more factored form, where I factored out that e to the x, it makes it much easier to solve that. Because just like when you solve a quadratic by factoring, you're using the zero product property, which basically says if I make this equal 0, because it's being multiplied by everything else, the whole thing will equal 0. Same thing if I set this equal to 0. And so that's what I'm going to do in order to solve this, is I'm going to set each of those individually equal to 0.
Logarithm.
So, what makes e to the x equal 0?
Log. Ln of
So,
T and e.
technically, in order to solve it, yeah, we go ahead and turn it into a logarithm. It'd be the natural log of 0 equals x, but the natural log of 0 is undefined. There isn't one. E to the x equals 0. Notice if you graphed e to the x, your graph would look like this. It has an asymptote here at 0 because it never actually hits 0. And so for the e to the x part equal to 0, there's no solution. So we're not going to get any zeros out of that part of it. All right, so now that we looked at that, we now have to look at the other part. We need to have 0 equals cosine of x minus sine of x. Well, right now this looks kind of unusual, kind of awkward the way it's written, so let's clean it up a little bit. Let's move that sine to the other side. I'm going to go ahead and add sine of x to both sides of this. If we do that, we get sine of x equals cosine of x. So, when does sine equal cosine? Well, for that, you need to know your unit circle.
Pi over 4.
So, the first time it happens is when x equals pi over 4. But then from there, it happens again at 5 pi over 4, and again at 9 pi over 4. Basically, it's the same pi over 4 plus pi as many times as you want it. So we write that as pi k, where k is an integer value here. And yes, this is our final answer. There's technically an infinite number of solutions because there's an infinite number of integer values that we could plug in for k, which is the beautiful part about being able to write it this way. But with these circles, these are all the different ways that we can get a horizontal tangent. So it keeps coming back to a horizontal tangent at every single one of those values. So if we're going to find the second derivative, we start by finding the first derivative, of course, which is actually what we just found on the last problem. So we already know what the first derivative looks like. Now I wrote it two different ways here because you have some options about how you approach this. You can go ahead and work from either of these two forms to find your second derivative. Now think about the pros and cons. It's a kind of a personal preference thing. If you're going to work from that first form, you're going to have product rule and you're going to have product rule.
Two product rules.
Either way works. If you're going to be doing it with the second form, you're going to have product rule just the once, and you'll just keep that as its own derivative. When you work with that part, you'll find the derivative of the difference there. Now, for each of you, work with the one you like the most. For me, I kind of like the second one a little bit more. So I'm going to go ahead and work with the second one. I think it looks a little bit easier. So, to find our second derivative, I'm going to do original times derivative. So that's the original e to the x times the derivative of cosine minus sine, which is a negative sine
Plus,
minus cosine. Okay? Then that is plus derivative times original. So that's e to the x times the cosine of x minus sine of x. Now, again, we can simplify things a little bit because we can factor out that e to the x out of both terms.
Yep.
So let's go ahead and do that. So f double prime of x is going to equal e to the power of x times negative sine of x minus cosine of x plus cosine, minus cosine plus cosine.
It all equals 0.
That goes to 0. So the cosines just cancel each other out. That's nice. Okay. Minus sine of x. Well, those don't cancel each other out.
But it'd be negative 2.
But I can actually simplify that a little bit more, though. So that would equal 2 times sine of x. So I'm going to call it 2 e to the x sine of x. Actually, that's a negative 2.
Yep. There you go, Mr.